Hi, this is Sean Wildermuth. Welcome back to another Coding Shorts. Today we're going to be talking about null coalescing and how null works in C#. There's been some confusion about null and not nullable and nullable types. We're going to cover a little bit of all of it and give you a brief sense of exactly how to use null in your own applications, or in some cases, to never use null at all. Let's get started. So let's talk about null. But before we can, I'm going to have to apologize. We're going to have to dig a little deeper than usual. I need to first talk about the idea of stacks and heaps. I know some of you are rolling your eyes already, but give me a second. It really is important. The idea behind the stack and the heap is there are two places where you can allocate memory. Now, the stack is essentially a quick-to-access piece of memory that is attached to a scope inside of C#. So that if we have a method like this, and we create a couple of variables, x equals 0, y equals string, when this scope disappears, these go away, but they aren't garbage collected in the simple way you might think about it. Because this whole stack of memory is simply destroyed so that the next stack, or stack frame as it's called, can use it. If it doesn't go out of scope, then each successive call deep in the call stack, which I'm sure a lot of you are familiar with, has this small local area. And so the stack is important because it's used for these small pieces of information that we want to store very briefly and then just get rid of. But anything created on the stack isn't garbage collected. It's an important idea to keep in mind. Now, what is stored on the stack? Variables that are value types. This includes primitives and structs, and there's a couple of others sitting in there. But essentially anything that is a simple type is going to be created on the stack. As long as it's not attached to something that's not created on the stack, like a class, it's going to be created on the stack. And so if we create, let's say int there, and we'll do the same thing we did before, right? Only one of these is actually created on the stack because this string, and string's sort of a special one that I won't dig into too much, is what they call a reference object. Now, a reference object is an object that is created on the heap. Heap is this much larger area, a little more lengthy to get to, and is managed by the .NET runtime. So when you allocate an object, it creates it in the heap, and then the garbage collector comes around every once in a while and starts to clean up and deallocate those objects if they're not referenced by anything anymore. And so the whole notion of garbage collection. Now, why does this really matter? If we look at a couple of types, we see the integer there, and we can see a Boolean here. That's also a value object, but so is this, right? This struct, which is different from a class, is just a structure of data. And those can be stored on the stack and created and destroyed very quickly because they're on the stack. And so you'll see sometimes using structures instead of full-blown classes in order to deal with objects that can be destroyed very quickly. So why does this matter? It matters because the other kind of object that we're going to be talking about are reference objects. So when I do me equals new object, this is a reference type. And in fact, this local variable is pointing to an address somewhere in that heap. It's been created for us. We managed by the memory, and only these types, because they're not value types, can have a null associated with them. So what happens if we do integer x equals null, right? Go ahead and make this an object so that it knows what type it is. It's going to hate this because it cannot convert a null to int, because this int has to store an integer. It has to store an integer. No matter what you do, it has to store an integer. And so because of that, just like a bool, can't be null because it has to store true or false, right? Because it can't convert it. It is just a value. There's no notion of, is this null or not? And so you've probably seen in your code a lot where you can say things like, if me equals null, then I'm going to do something, right? And that's really what we're talking about in this notion of how do we deal with null? And it's changed over the years, right? Let's say we have this object of null, and let's say this variable is still an object, right? Me is an object variable, but happens to store something that is a reference to another type. And so one of the things you'll see a lot is, especially in older code, and what does this do? This says, please try and convert me to a string. And if it doesn't, then we've done something wrong. This should have been a string. In fact, this could be null not only because this was a string, but also if it were null. So in either case, this us gets assigned to a null, and we can do that. You'll also see simple casting like this, where, well, you know what? I know this is a string, and if this can't be converted, what happens? It throws an exception. And so we have cases where we need to think about and look for whether null is being created or not. Now, this is a pretty simple and pretty useless demonstration because we're talking about variables we're creating and then variables we're not loading. So let's talk about something that's a little more real world. So I'm going to create a collection called people, and I have a person class that happens to have a way to just get us a bunch of people. This is actually a JSON file in my project. And you'll notice that the structure of here is that it has some data for some that it doesn't have for others, right? This is a pretty common case for us reading CSVs, JSON files, getting data from an API, all those sorts of things. We don't always have control over what is being sent, especially when you start to think about databases. Databases have this notion of this is null as well as this exists. Instead of it being something like an empty string, it might be null. And you're going to need to deal with that. And so let's go through our person and people, right? This is just a simple class that includes ID, name, age, etc., and also has an address. So it has sort of this two-tier structure to it, but we're not going to dive into too much. And so one of the first things we might want to do is convert this to another object we have. Like, let's call this our customer. New customer. And then I'm just going to copy some fields over, right? One for each of these, I'm going to go ahead and do something with. This is such a common occurrence in any programming language that you've probably done this before. So ID equals person.id, right? That's great. Name maybe, okay, it's the same thing. Age and favorite color equals person.favorite color, right? So all of that's just a one-to-one comparison, but we might also have like street address, and we're going to need to dive down into the address.street address. And let me just copy these so you don't have to just watch me type. Let's go ahead and say apartment, suite, city, state. I'll copy one more for zip code, right? And let's just change these to apartment, suite. I happen to use the same names. A lot of times this won't be the case, but that's not really what we're trying to deal with, right? And let's say zip code, right? And we'll just write line our new customer, just so we have it output. And I'm just going to use this is just a console app, so I'm just going to go ahead and run this. And immediately we get that dreaded null reference exception, right? We have some part of this that we don't have filled out. Is age not real? Is favorite color not real? I'm trying to instantiate it. We need to have a way to check this. And so, you know, in the old days, we would say something like, just do it up here to be easy. And you probably would write little helper functions here. So if address exists, then do that. Otherwise, just give me an empty string, right? We can do these with sort of that question and answer. And I have to do all this, right? If person equals null, if address does not equal null, then let's check it. And this is where the idea of the null coalescing argument really comes in. So we don't want to do all of this. And this, one of the things that C# now allows us to do in C# 9 certainly, and I think from 7 and forward, is instead of this, we can actually do question mark, right? We can say our street address, let's bring this all the way back, is going to get the street address. And what does this magic question mark actually do? This magic question mark says, the address is null, just return null, right? Collapse this, so this isn't going to throw an exception anymore. It's just going to say, you know what, a street address doesn't work. Let's go ahead and just do that if address is null. Let's put those in all those places, and let's run this again. and it no longer defeats, because what happens is when the street address is not null, it goes ahead and pulls that data in, and then we can see that those addresses are blank for Gene and Bob because we don't have them. We don't have that necessary piece of it that we actually want to do. And there's two other operators that are important here. In the case of these, we're going to return a null if the address is null. That may or may not be exactly what you want to do. So let's go ahead and just put a little divider in there so we can see the separation. Let's go ahead and run it again. And so we can see each of these different items exactly the way we need to. But what we're going to actually see here is that what we're going to get here is street address being null. This might not be what we actually want. We might actually want to go ahead and return a default value. And that's where we can actually use the double question mark as well. And double question mark says, hey, if this returns to a null value, default it to whatever's on the right-hand side of it. And so in this case, I'm going to say none, just so we can see what actually happens. And I'll put these on each one of these as well. And this may not be something you want to do for each one of them. You may want to do this just for a single object, but this is a shortcut for saying if address is null, then do street address. And if street address is also null, go ahead and just do none. Because remember what this question mark is saying is whatever this is, we're going to make sure that if it returns null, both at the address or at the street level, that we're going to just say none. So let's run it one more time. Right? I get none, none, none because there was no zip code on this bottom one. And then we're getting it for all of them because there wasn't even an address. We're getting really the behavior we want in both places. So the last one I'll talk about is one that's probably the most confusing, and that is question mark equals. So if we down here, let's get out of the for each. Let's say down here we wanted to actually store a person. And so let's say our person here, we could say cust does not equal null, cust colon new person. And this isn't really going to work because let's actually do this. Var new cust. Just so we have it. This is sort of the old way that we would do this, right? We would say, you know what? Let's create this. And if the cust is not null, let's go ahead and use the customer. Otherwise, we'll just create a new one. And this is a pretty common case. The shortcut for this is to actually just say customer, new cust, question mark equals new customer. And what is this really replacing? We're telling it, instead of saying if new cust equals to null, then new cust equals new customer, right? This is a way, especially defaulting values inside of a method or inside of a constructor. This is just the shortcut. These are exactly equivalent, right? If new cust is equal to null, create the new customer. Here it's just saying, hey, if this is null, go ahead and assign it. This is the default value. And so we're really looking at three important cases here. Question mark, double question mark, and then question mark equals. Now the last piece that's important here is I talked about stack versus heap, and that we're really talking about null as only being related to reference types. The only exception to this is if we go ahead and look at the customer class, we'll see that we've put a question mark after the type. And that means that we're going to allow that to be nullable. Now, we're not using nullable reference types, which is a feature you can enable in C# 8 and beyond. I believe it's 8. It might be 7, but I think it's 8. So we're telling it, and this is especially true for value types, right? We're saying this age is actually a structure that can be null. And so for age here, we could do the same thing and just say 50, right? If age isn't specified, because this is a nullable type. Because age is a nullable type, what does this really look like? Person.age.has value and then value. These are compiler-built wrappers around those value types or reference types to say that this possibly could be nullable. And in fact, is more clearly defined as what nullable is, right? And so in that case, we can use that to define what we're going to do. Oh, and of course, my customers aren't showing their age, so let's do this. I've got a little override for toString just so we can spit it out, and I'll go ahead and put age in parentheses. Run it one more time so we can actually see the age work. Right? Notice 50 and 50 because in our JSON, only one of these actually has an age to it, and that is Bob. The other two are missing the age, and therefore we're defaulting it for output to 50. Because age, as far as it's concerned, is nullable. Well, this takes us to kind of the last piece of this, and that is nullable reference types. I know some of you have heard it, and when you've tried turning it on in C# projects, and I'm like, oh my God, there's a billion errors. Let's talk about what it really is doing. So let's look at our CS proj file, and we can say nullable enable. What happens if I go ahead and build my project, right? I'm going to start to get all these warnings. And these warnings are about the models.cs not adhering to this. So let's look at what that models.cs looks like, and we'll immediately see these complaints. So there's something interesting happening here. I'm saying that name, favorite color, and address all have to be set. And so what Nullable is going to do for us is it's going to say, let's make sure that these are all value types. Because what is interesting over here is we won't have to test any of this, because our class itself, like this person class, will dictate whether something's nullable or not. Notice the age is nullable here, but string should never be nullable in this case. That means favorite color is required. So let's go ahead and put a question mark after that, because in truth, favorite color isn't required, but name is, right? And so in our case, I'm going to tell it that the default name is going to be empty, and the address also is nullable. And so what turning on nullable is really doing for you is saying that this class is going to dictate that there is this additional value that you could have, and they want you to be explicit about it. At first, you might think this isn't going to really help us. But what this does is it prevents you from ever needing to check for null for a reference type that isn't nullable. So let's go ahead and look back here. When I create this new customer, I'll never have to check to see whether this customer, I'll never have to go, if cust is null, or in the new parlance, is null, then do something, because cust can't be null. Now in our case, we can see that it created it with the nullable by default, because that's what it's inferring from the var. But if we say customer here, without the question mark, what happens? And so we can see the compiler is now saying, hey, I know that this type cannot be null, because this type isn't nullable by default. We're going to have to put a question mark after it to make it default, just like we did the properties when we looked at that. And so what this means is you're having to test less and less for null in your code. So your code becomes cleaner because you know that for instances when you don't need nullability, that it isn't turned on by default. Only thing to be aware of is, notice that this cust isn't nullable, but that if we do var, it's going to infer by default that customer is going to be nullable. So just be aware of that, because it doesn't know what is going after this except by the type. So the var can make that a little bit more confusing. And so if you turn this on, you are going to get a ton of exceptions, because remember that in each of these classes now, when you turn that on, it needs to have a value by the end. So let me show you a quick example of that. So in our customer, I don't want name to ever be null, but I also don't want it to just be an empty string. And so what do? I had a constructor for customer that has string name equals name, right? And so this is satisfied as long as at some point, let me comment this out for a minute, this is going to complain because name must contain a non-null value when exiting the constructor. So you don't have to have a default here. You just have to have a default by the time the constructor is done. And so in this case, I'm forcing it to pass in name, and then here in program, I'll just have to do person.name, right? And then I don't need to set it in the object because our constructor is taking care of that for us. And we'll see all of this sort of start to fail because I added a required constructor, and we sort of go from there. Hopefully I've given you a taste of some of the questions you might have about null and how it relates, and some of the newer features about null coalescing operators, as well as nullability in your C# projects, and why that could be, especially for large projects, a benefit to having code that throws errors at compile time instead of runtime. Remember that this nullability is going to be checked when you compile the project. And so you can see what those expectations were when you actually wrote the code. Is the expectation that this object will never be null? Therefore, you don't need to ever check for it. And this actually cleans up a lot of constructor code, where if someone passes a null object into a constructor, we used to do all these asserts to make sure they were true. Nullability gets rid of all that because you know that the compiler said there's no way this is going to happen. This cannot happen, therefore your code becomes simpler. This has been Sean Wildermuth with another coding short. Thanks for joining me.